Okay, hi everyone. Can you all hear me? Great.
Yes.
Good morning, everyone. My name is Justin Peters. I am the data manager for the Environmental Resilience Institute at IU. This is our fourth ERI Data Summit that I've hosted in that capacity. And I want to thank you all first for registering and attending today. We have quite a bit more attendance than we have had in the past. We've opened this event to the public. In the past, it has primarily been ERI affiliated researchers that have taken place in this summit. So it's great to have some additional participation from those that may not have attended these in the past. We have some great presentations lined up within the next couple of hours. As you can see in that schedule there, I think everybody should be able to see that schedule. We do have one change to the schedule. The urban green infrastructure, the food security, edible trees, and equity in Bloomington and Indianapolis, that was to be presented by Aaron Hardman and Ava Hartman. We've got another speaker lined up at a presentation, and I do not remember the title of that presentation, but Dana Habib will be presenting, and she'll be able to provide that title here in a moment. So to kick things off, I am happy to introduce the new ERI co-directors of Gabe Filippelli and Sarah Mincy for some opening remarks before we start the presentation. So presentations. So Gabe, the floor is all yours.
Oh, great. Thanks, Justin. And good morning, everybody. This is going to be a great set of talks. I look forward to and seeing it as well. Sarah and I started off as directors just about a little over a month ago. And we're super excited. ERI is in this amazing place where we're really able to highlight the data that we've been able to get now from funded research and start to think about how to implement that data, both for research practices and also for teaching and community impact purposes. So I think that's what we're going to see a lot today. And what I think is kudos to Justin and the data team for pulling together some platforms, really thinking through how to make data both discoverable and shareable and viewable and accessible to all. Sarah and I, when we came in, we have a commitment to supporting ERI as it's already been going, which is extremely successfully. But also thinking adding a couple components, including having ERI perhaps embedded a little bit more deeply in the curricular mission of the Indiana University as a whole, as well as making sure that we keep an equity lens on much of what we do. And some of the talks you're going to see will clearly have that equity lens. And I think it's an exciting time to be associated with ERI. Everyone's talking about the environment and climate and the critical nature of that, as well as how it intersects with equity. So I was so thrilled to take this position, and I'm also so thrilled to have as my co-director, Sarah Mincy, who will transition us to the next phase.
Thank you, Gabe. Yes, I'm pleased to be here too. Thank you, Justin, for the introduction. Thanks, Gabe, for those comments. I think you're right. We're going to see a lot of our presentations today focus on data that will support both of those new missions. A lot of the data is going to be available for teaching resources, I think, for faculty at IU, but beyond, educators beyond IU. And the equity focus is certainly going to be present today, so that's exciting. I'm a researcher within the first group of presentations, the Urban Green Infrastructure Group, so I'm really pleased to transition to introduce this group of fine researchers. We're going to have 4 different presentations that will give you a really good lens on a product that our group has produced called the Green City Mapper. And first up will be Hannah Gregory, who is a research assistant with our group. She graduated a few years ago from IU from the environmental science program, and she has worked across the university in multiple roles, but we've been happy to have her as a research assistant with the Urban Green Infrastructure Group. Next up will be Dana Habib. Dana is a professor in the School of Informatics, Computing, and Engineering, and she's going to talk about urban heat and how we can deal with that. Following that, I think we will have Stephanie Freeman Day, a PhD student who's been working with me in urban forest management and on social ecological systems. And she's going to talk about a part of the data, part of the mapper that focuses on more of the social and institutional data, sort of the management and planning side of urban forestry. And then Samantha Hamlin, who is a postdoc with the UGI group, will talk, and she's going to give us a good overview of how we can start to apply some of the wonderful data sets that we've collected in the mapper. So with that, I think I will turn it over to Hannah. Hannah, I think you can share your screen and take it away.
Okay, so thank you for the introduction, Sarah. Just a little more background on me. As Sarah said, I graduated from SPIA in 2019, and I previously worked as the Environmental Practices Coordinator for IU Landscape Services, and the biggest project that I worked on and completed was the 2019 Campus Tree Inventory and the related analysis with that. I've been a research associate with the ERI's UGI and Urban Forest Group for a little over a year now. And my primary role has been developing and updating the Indiana Green City Mapper, which I'm going to be reviewing for you today. So the purpose of the Indiana Green City Mapper was to condense research from the ERI and from other existing sources relating to socio-ecological and climate data into a single source that can be, or that's interactive and easily accessible and also user-friendly. City governments can use this Indiana Green City Mapper as a resiliency planning tool to prepare for impending climate challenges like heat stress and flooding, and can also help them address community needs such as food insecurity and access to green spaces. Community members themselves can use the mapper to equip them with the knowledge they need to encourage the change that they want to see in their communities. And also for personal use. And of course, the mapper is going to be beneficial for other like-minded researchers wanting to do similar work. The three main data types that we have represented on the mapper is urban green infrastructure, social, and climate data. So under the urban green infrastructure, there's 6 subgroups: forest, food and agriculture, stormwater, green roofs, parks, and trails and greenways. And in the social data section, we have socioeconomic indices, food deserts, and urban forest climate change planning layers. And lastly, some examples of the climate-related data that we have represented on the map are urban heat island intensity, local climate zones, and building height data. Due to the proximity of our researchers here in Bloomington and at IUPUI, most of the data does have an initial spatial focus that's limited to Marion and Monroe counties, with the exception of urban forest data, which does span across the entire state and is really comprehensive. But we do have plans to expand spatially moving forward. So I'm going to start with a quick platform overview. This is just a screenshot of the platform when you first land on it. So you have the typical map elements of like the zoom bar, the layer menu, and the legend. And then there is a platform directions window, which I strongly encourage you to read before using the platform. It'll help show you how to use the widgets and give you some more in-depth descriptions. There's an attribute table at the bottom that you can pull up to view the corresponding attribute table to the layers that you have on the map. And then to the left, there's a widget bar, and I'll be talking about the widgets here shortly. So this is the map once you have, or an example of the map once you've added some of the layers. So you can see the layers on the map as well as the corresponding legend and the attribute table at the bottom, which is pulled up. And as you select the data points in the attribute table, they're highlighted on the map. There's the widget bar to the left, which is open to the filter widget. And yeah, so now I'm going to talk about the widgets. So the widgets were created to kind of help customize the user's experience when using the platform and to make the data more interactive. So we have a filter widget, which has some preset filters that focus on a certain field attribute across several different layers, and also allows the user to create their own filter. There's a group widget that includes changing base map and adding data. So users can change the base map to aerial imagery or any of the other bases that are in Esri's base map gallery. And they can also pull in their own data that's either housed in ArcGIS Online or in a file on their computer. There's a selection tool, and the selection tool can be used to export data based on the user's selection. And it can also give some quick statistics and highlight data. There's some pre-made charts that the users can execute, and also some basic info summaries that can summarize the number of points as you zoom in and out of the map. The tree inventory, since it is so complex and data heavy, it has a few widgets to itself. There's a size infographic and diversity infographic, and also another summary of the diversity indices and other information that we've conducted on the tree inventories. And there's more widgets to come as more data is added to the map. In the layer menu, there's some options to change the transparency and visibility range of each layer and rearrange them by moving them up and down to create a more customizable map experience based on what data you want to be viewing. And the Show Items Detail button links out to the Layers Information tab or page in ArcGIS Online. And there you can find a more in-depth description of the layer, and soon you'll be able to find the metadata that attaches to the layer as well, which is in the process of being uploaded. You can also export the data from that page as well. So I wanted to show a quick example of the Indiana Green City Mapper in action to jog some ideas on how it can be used. We're going to look at the patterns between urban gardens, urban heat island intensity, and urban canopy cover in central Indianapolis, and also pull in some additional data that maps brownfield locations in downtown Indy. And just to recognize a caveat, these observations are just for the purpose of being an example of identifying data patterns, and they haven't been analyzed past this first step, and a spatial quantitative analysis would need to be used to confirm or assess the significance of the patterns. So the map on the left is a screenshot of the Indiana Green City Mapper. It has the urban heat island intensity map, the canopy cover, and then the blue points are the urban agriculture and gardens. And on the right, there's the urban agriculture and garden points, and it's layered on top of the land cover zones, and the red and orange scale represents developed areas. And similarly, the red areas in the heat intensity map represent heat stressed areas. So the pattern that we can recognize is that urban agriculture and gardens are mostly found in developed areas with higher canopy cover and more outside of downtown. And the higher heat index corresponds to less canopy cover and less urban gardens, as you can see in especially the central downtown area. So this is the same two maps, but instead of the urban agriculture, it shows brownfield locations. Just give you a second to look at that. So the brownfield areas are super dense in downtown Indy, and that also corresponds to more heat stress, lack of canopy cover, and fewer garden locations. So the brownfields might offer an opportunity to increase canopy cover by planting more trees, decreasing heat stress by means of planting trees and increasing canopy cover, and also provide spaces to develop urban gardens. So in this way, or using the Indiana Green City Mapper in this way, helps to identify solutions to these emerging climate and socio-ecological issues, and can help cities begin to answer important questions like what areas need more trees planted to eventually reduce heat stress, especially as the climate changes, and is there vacant land that could be used to address food insecurity. So we're beginning to turn our focus towards how we should update the platform, and we're welcoming some ideas on best practices on how to do that. So if you have any insight that you'd like to share, feel free to shoot me an email. We also have the goal of spatially expanding the data layers that we already have, as well as eventually inviting new data that we don't have represented on the map yet. We already have some funding for this through the DNR and the Institute for Advanced Study, and we're working on securing more. Please feel free to reach out to me if you have any questions. And thank you for your time. I don't know if I have any questions or any time to answer questions at this point, but.
I think what we were going to try to do, Hannah, is hold on questions. Maybe we'll get through the presentations and then open
Okay,
it up.
perfect.
Yeah. But thank you so much for that presentation. As you can see, and as Hannah suggested, the Green City Mapper is really framed by resilience theory and social ecological systems theory. We're really interested in trying to link up this variety of data to try to think about how, as we move forward and experience climate change, how can we help mitigate that, and how can we help people adapt and identify problem spots, but places where there are opportunities, like Hannah just showed. So next up is a little bit more on that topic with Dana Habib. Dana, I'll turn it to you.
There we go, I was muted. Thank you, Hannah, for that great presentation of showing our data platform. So what I want to do now is actually take you through one of the climatology, one of the climate variables that we have. And so we saw a lot on some of the heat, urban heat island intensity, and a little bit of local climate zones. And so I just want to right now take a little bit of time to describe what are local climate zones, how do we create them, and how can they be useful? So just a little bit about myself. I'm an assistant professor here in IU at the Department of Informatics. My background is in urban design and environmental urban planning, focused on urban climatology. And my research is really centered on how the built environment impacts climate change and climate change impacts the built environment. Strong focus on extreme heat and that impact to community health. And it's been a pleasure working with this great team to develop this platform. As we see with extreme heat, more people die to extreme heat in the United States than any other natural disaster. And we see that cities are particularly vulnerable to extreme heat because of what's known as the urban heat island effect. The urban heat island effect occurs when we see that temperatures are higher than their surrounding rural areas. And this temperature differential is due to basically how we're designing and building cities. We're displacing natural vegetation and replacing it with impervious surfaces such as buildings, roads, and parking lots. And all that goes to elevate temperatures in cities. We don't just see a difference between urban and rural when we're looking at the urban heat island effect, but we actually see that temperatures vary dramatically within a city. And so we can see temperatures increase by as much as 25 degrees Fahrenheit within one city. And so it's really important for us to be able to identify these microclimates and understand those heat exposures for these specific areas, as well as the communities that live there. So urban climatologists have developed what's called these local climate zones, which are basically these urban form typologies. And they're derived by specific urban form parameters that we know impact and drive temperatures. And so we can imagine like a downtown area in Indianapolis is going to be a lot hotter than a residential area. And so this work really goes to be able to identify those areas. And so the local climate zones are actually divided into two main categories. They're divided into the built type and then land cover type. Within built type, we see examples like compact high-rise, like we would see in a downtown area, or a more sparsely built area that we see more on the edges of cities. There's 6 main parameters that go into defining the urban heat out, the local climate zones. The first 2 are sky view factor and aspect ratio. Both of those are dealing with the urban morphology of a city and really capturing or addressing measures that capture and retain heat in cities. The sky view factor is the percent of the sky that is visible from the ground. The aspect ratio is the ratio between the height to width ratio of a street canyon. And then we have more land cover variables like impervious surface fraction, which is dealing with the percentage of impervious land cover, impervious in an area, as well as the amount of building surface that is in an area. And the last variable is height of roughness, which is really dealing with the average building height and as well as vegetation height. So for our our data platform, we classify local climate zones for both Bloomington and Indianapolis. We did a supervised classification using a random forest model. And basically what we did is we identified training sites for each of the local climate zones for both Bloomington and Indianapolis. We wanted to compare this classification approach to 3 different models to kind of see what would result in the best approach of doing this classification. And we did the majority of all the classification in Google Earth Engine. So for our urban form parameters that we actually used in one of our models is that we used aspect ratio, calculated that, as well as building surface fraction, impervious surface fraction, pervious surface fraction, and roughness height. Specifically, we used the statewide LIDAR data to estimate the average building heights for each of our zones, as well as the average vegetation height. And what we actually determined was that these 2 last ones, roughness height, were the most important variables that we added into our models. So here's an example looking at Bloomington when it's classified based on local climate zones. And we can see what we'd expect, the more intense development happening in the center of Bloomington, and then towards the edge we see more of the sparsely built and the open low rise. We have approximately an 88% accuracy with our local climate zone classification for Bloomington. And here is an image for Indianapolis, looking at our local climate zones here. We again see the more intensity of development with compact high-rise, compact mid-rise, all happening in the downtown area for Indianapolis. And our model here was upwards of 94% for our accuracy. And this is important, again, for communities to be able to identify areas that are going to have the highest heat exposures, but also to be able to identify which urban form parameters are actually driving these temperatures. Cities can then really, by understanding which urban form parameters are driving temperatures, they can then target policies that are appropriate to those levels and those urban form, those microclimates in order to reduce those temperatures. And so moving forward, what we'd like to do is we'd like to do a classification for the state of Indiana. And so there's a big movement right now to do these local climate zones across the world and to share these, the mapping, the classifications on a data platform. And so one of the recent classifications have been for a much larger scale across the entire United States. And so we investigated the United States classification and compared it to our model and was able to show that these very large regional models are actually not as effective for Bloomington and Indianapolis. And that really what we're determining that's really separating this is that we just don't have enough training sites, or they didn't have enough training sites in order to really train those models. So developing those local training sites is really important. So moving forward, this is our first attempt at looking at doing the statewide for Indiana, where we'll be selecting the correct model to be used. We'll be adding additional training sites. We'll add additional satellite data by using Sentinel-2. And then we're also going to be using a normalized digital height model from the state that's generated from the statewide LIDAR data set in order to move forward with our work here. Thank you so much.
Thank you, Dana. That's such fascinating work. And obviously is going to be a really big resource once we've got it for the state. It's amazing. We are going to transition over now to Stephanie Freeman-Day, and she's going to talk to us about the planning and management data set that we have within the Green City Mapper. But real quick before I turn it over, Stephanie, I just want to remind folks to, if you've got questions, go ahead and feel free to type those into the chat, and then we'll have a collection for a Q&A after everybody's done, or you can hold on to them and I'll call on folks later. Go ahead, Stephanie.
Hi, everyone. Thanks for the introduction, Sarah. As she said, I'm Stephanie Freeman-Day. I'm a PhD student in environmental science at O'Neill SPIA, and my main research focuses are on urban ecology and urban forests. So I'll go straight into kind of introducing this data layer. First of all, as many of us are aware, municipalities are increasingly using urban forests as a strategy in climate change for both adaptation and mitigation. This is for a lot of good reasons. You can see the multiple studies that I've cited on the left-hand side. Urban forests have been connected with cooling of the urban heat island that Dana was just talking about, stormwater capture, provision of shade, carbon sequestration, and all of these are ways that urban forest has been used in management of climate change impacts. But here's the catch. Urban forests are also sensitive to climate change and impacted by climate change. So we know that climate change impacts the health of urban forests in Indiana. There are increased temperatures, more intense storms, spread of invasive pests. And so we asked this question, how are urban forest managers preparing for climate change? Because like we would maintain technology, urban green infrastructure like urban forests also needs maintenance. And some of these resilience strategies that are suggested through research include increasing species age diversity, planting species that will do well in current conditions as well as future conditions, and planting in areas with lower canopy. The image that I have on the right-hand side of the slide is just one way that climate change can and does and will impact urban forests now and into the future. You can see the plant heat stress defined as days with high temperatures above 86, increasing from historical averages in now and into the future. So that is just one part of climate change that needs to be considered in urban forest management as far as climate change impacts go. So a little bit of the background on the data collection for this layer is a little unique in that the data collection begun with a separate research project that was started by Bernie Fisher with grad student Donovan Moxley in 2017, looking for active urban forestry programs that were preparing for climate change. And I joined the group shortly afterwards, and we continued with this project and defined planning for climate change as the presence of institutional components. Working with another grad student, Charlie DeVoe, who created the map you can see on the right. This shows the 74 active Indiana municipal urban forestry programs that met the definition that we came up with. And then we further adapted this index with Sarah Mincy and Sam Hamlin at UGI in the terms of urban forest resilience. And that's where we came to the point where the layer is the way you can see it now on this slide. The image on the right is actually a screenshot of the urban forestry municipal climate change planning layer. I'll go through the pieces of the index with you. There are 8 components, and I'll say they're not weighted. Each one is either a municipality has done this or doesn't have that quite yet. So Tree City USA member for 2018, funding from Community Urban Forestry or IDNR in the past 10 years, a tree inventory in the past 10 years, arborist or urban forester on staff, a municipal tree ordinance in place, a tree inventory report and analysis done by professionals in the past 10 years, a dedicated urban forestry program within the city, and also an advocacy group such as a nonprofit that's connected with municipality, either planting or tending trees or educating people about the benefits of trees. And so you can see, well, first of all, I'll talk about these components, why they're important and how they're connected with resilience. This is with funding and dedicated resources, knowledge and expertise about the urban forest, data to inform decision-making, and also connectivity within the community. So you can see this screenshot shows the 74 municipalities that are part of our index, and the number of components that they have, that we've seen evidence that they have. So the number and then the size of the dot can show you these communities. And just a little background and some background statistics, descriptive stats. So as I said, 74 municipalities meet the definition of having an active urban forestry program out of 829 incorporated places in Indiana. So we're looking at the 9% who are doing the most planning for sustainability and resilience with climate change. And as you can see, most of our programs have up to 3 of those components, with last numbers having 4 to 6 or 7 to 8. So again, we're really looking at the leaders in planning for resilience in the urban forest. So with that, just looking into the future, both with this data layer and broadly into urban forest climate change planning, any layer updates, we probably will see new municipalities, either we've discovered that are taking steps in planning for resilience of the urban forest, or ones with growing urban forestry programs that start planning for this sustainability in this way. An updated index could include specific climate change planning, inclusion of the urban forest and sustainability or climate change plans citywide, or urban forest plans that explicitly incorporate changing climate with management of the urban forest. And finally, we do see this Green City Mapper as a tool that can foster social connectivity between cities, where people can share strategies, people can share plans, and do some regional climate change planning that incorporates the urban forest and also considers the urban forest and its needs. In general, increase urban forest resilience, but also broadly general community resilience. And thank you. And that's what I have.
Thank you, Stephanie. That was great. Yeah, I was just thinking about your last point about regional climate action plans and how they're becoming more popular. And you can clearly see on the map, there are regions where there are cities that are doing so much in terms of urban forest planning that could really contribute to those regional climate action plans. So I think this is a useful tool for that reason and others. Next, we're going to turn to Sam Hamlin, who is a postdoc with the UGI group. And Sam is going to show us some interesting application of the Green City Mapper, which really speaks to one of the real focuses of ERI in terms of environmental justice and equity. Go ahead, Sam.
Thank you, Sarah. So yes, I am an environmental geographer with our project. And so my interests are all things green infrastructure and all things water. But this time I'm looking at trees. And so Stephanie has given you a really good idea of why we would be looking at trees. And one of the questions we had with these robust data sets is thinking of resilience. What about social equity? And when we start looking at the literature, a lot of times equity is evaluated in terms of canopy cover, which is the quantity of the trees. And we started looking at thinking about the quality of the urban forest. And when we started looking, there were some meta-analyses, and we were seeing that there was a fair amount of inequity in urban forests in terms of both race and income. We also see significant inequity with tree canopy coverage on public land, but there hasn't been a lot of research done on tree quality. So that's the piece that we thought, we actually have these tree inventories. We have this really rich data set. We can start to look at this. So this is kind of the background to what we were doing. And we have been developing, this is some pilot research, which I'll return to at the end why it's pilot. But as we were working on this research, we've also been working on the mapper. And we were thinking, first question, canopy cover has been used so much and it's quite a bit easier as far as analysis. Can it still be used, and still get an accurate assessment of equity? And the other thing we were thinking about is, the data on the mapper, this is public data. And this is, these data can be used by planners to do a deeper dive into, planning questions they have for their own community. And so we wanted to do this pilot work and see what that might look like. And what we decided is, is urban forest quality equitably distributed in the city of Indianapolis? Okay, you can see two schools there where not so much. But so we calculated the Shannon Diversity Index at the census block group level in Indy. And so this is looking at species richness and species evenness. So these were straight out of our street tree inventories. And then to look at some of those social data, we looked at population density, we looked at poverty, we were looking at different racial compositions, and particularly percent Hispanic in a census block group or the percent Black population, educational attainment, and then the building age, which give an idea of the age of the development. We also wanted to control for the plantable area, which to do that, we calculated the street length per census block group. And I don't want to go too deep into the weeds here, but we did a spatial regression. And here is the final output of what was significant. So we see an R-squared of 0.27, and it's these bottom three that we are most interested in: the education, poverty, and the percent of Latino population. And specifically, we see that poor communities have less tree diversity in their street trees, and marginalized communities, particularly Latinos, also have a lower species diversity. I also want to point out that areas where people have a higher education, they have more street tree diversity. So unfortunately, we're seeing that yes, there is inequity in urban forest quality in Indianapolis. So the question is, so what? What are the implications of this? Well, having strong, having a species diversity and species richness, biodiversity, it's a crucial underpinning to ecosystem services and to having more ecosystem services. So if we're seeing this lower diversity, it means these marginalized communities, they're not receiving the full range of ecosystem services. And it means in the future, they're more vulnerable to environmental change. And an example of this would be the infamous emerald ash borer. We've seen ash trees get just decimated, throughout the Midwest. If that happens in a neighborhood, then all of a sudden we're looking at tree loss, tree canopy loss, less shading, more heat vulnerability, more stormwater runoff, all of those things that Stephanie was talking about earlier. So those are the implications of this, or one implication of this. And for our next steps, as I mentioned, this is pilot research because we have a lot of street tree inventories across Indiana. So once we have really nailed down the method using Indianapolis, we'll be expanding this to about 20 other cities in Indiana. We'll be exploring other variables, especially other tree quality variables, like the age, structure, and tree condition variables. And also in Indy and a few other cities around the state, we'll be controlling for areas that were previously redlined. And with that, thank you.
Thank you, Sam. That was an excellent presentation. I see a few urban foresters who are on the line here, and I know that they have dealt with communities that have practically monocultures of street trees, often because that's what developers put in. And so they are well aware of what happens when you have a pest or pathogen that is species specific and it comes through and it destroys the community's canopy. And obviously loss of ecosystem services, how much more devastating to a community that's already a vulnerable community or marginalized community. So this is a really good application of the tool, I think, for people to be able to identify these issues and work proactively to diversify. So I have one question in the chat, and I'll go ahead and address that one. And then if others have questions, we can open it up, or again, feel free to type those into the chat. So Jerome Delbridge asks, he says, tools to identify areas of cities most in need of tree canopy, that those are important. But also identifying plantable spaces is another critical element. Are mapping tools available in the data set to show feasible planting spaces? And so, Sam, I think you addressed this a bit. Can you take that?
Yes. So we are looking at this piece of it, what would be plantable space? And the way that we are working on this, the data are not on the mapper yet, but they will be shortly, is calculating the right-of-way areas. So all of those areas that are outside of the vacant parcels as public land that are potentially plantable space. And we're also looking at how much canopy is already in those right-of-way plantable areas. And so that data will be available, like I said, fairly soon.
Great, and I'll just add a caveat to that, that of course we don't have details like utilities yet included in the mapper, but that would be something that would also help us narrow down what is actually plantable. Kim Cook asks, how can you draw connections between what we currently understand about urban forests and other types of biodiversity like mammals, bugs, and migratory birds? I wonder if maybe Heather Reynolds is another one of our teammates who's on the line, and really this speaks to her expertise. Heather, would you take that?
Sure, that's a great question. I mean, there is existing literature for sure. I think especially of Doug Tallamy's research lab in New Jersey. Look him up. He's doing fantastic work, and there's a lot of publications that show just how many different species of caterpillars, that turn into butterflies in particular, and that goes right up the food chain to birds, depend on our native tree species and the diversity of native tree species. The literature's there. I think it would be great to, if cities were able to add also, their own empirical work to add to the work that people like Doug Tallamy have already done. I guess I'm just agreeing that the connection is there. The literature exists to support that connection. And it's so important because we do need biodiversity at all levels. It all works together to create a holistic, closed loop ecosystem that provides the whole range of ecosystem services.
That makes me think about the EcoBlitz data sets that might be out there for urban wooded areas that we might be able to get our hands on and add in. So that just speaks to our interest in ending this with asking you if you know about data sets that you think would be good for us to be adding into the Green City Mapper. Please get in touch with our team. We really, really appreciate it. And we hope that you've seen some usefulness out of the tool that we've been working on for the last few years. Okay, with that, I think I'll wrap it up and turn it over to Justin.
Thank you, UGI team. That's some great updates from your work and research. Really neat stuff. I'd like to, at this point, turn it over to one of the ERI fellows, at least for a little bit. Matt Hauser has been working with the Hoosier Life Survey, and he's going to update us now on some of the second round of the Hoosier Life Survey and some of the, I guess, initial results. So with that, I'll turn it over to Matt. Matt, the floor is yours. Thanks.
Thank you so much, Justin. Thank you, Sarah. Wonderful work so far. Give me a second here. Okay, thank you for your patience as I navigate Zoom. Yeah, so I want to just share, this is very preliminary. I want to put a caveat on that. I'll emphasize that like 6 times in this. But this work is led by myself and Dr. Eric Sandweiss, but there's a large number of people on this team, including Heather Reynolds. Justin and Kimberly have been a key part of sort of our outreach program from this and have done wonderful work with the original Hoosier Life Survey. I will acknowledge everyone at the end, but I want to note that this is a big team collaborative effort and it's been super fun. So I think I'll begin just by stating the obvious. It's really been a hell of a year. If you look back, we had a global shutdown because of coronavirus. People are dancing in the city streets of New York. As a consequence of the shutdown, there's a global recession, huge economic impacts, particularly for people in the restaurant industry. We had a reawakening to issues of racial inequities and inequalities and the need for police reform. There's also a toilet paper shortage. I forgot about that until I was presenting this. You know, we had all this like weird stuff happen. In other words, we've lived through sort of multiple society shaking events in a short period of time over the last year. And I'm a social scientist, and you know, I can't help but wonder, how have individuals responded to this sort of structural shifts, these structural challenges? How have we changed? And specifically, I'm an environmental sociologist, and with the Hoosier Life Survey, I got curious, how did the public's climate change views and resilience behaviors change in Indiana as a result of all of the events going on in 2020? So there's not a straightforward potential here. There's not going to be a one-to-one. You know, one potential shift is that we see a decreased level of climate change concern and related behavior. There's not a ton of research on how these sort of structural societal changes impact individuals' environmental views, but what has been done is focused on the 2017 Great Recession. And that work suggests that as a consequence of the recession, we saw a national level drop in concern about climate change. There's a couple of reasons for this. I won't talk about it too much, but one example is finite pool of worry. The basic premise here is that you can only have so much anxiety or concern in your life. You know, many of us are probably at that point right now. And the idea is once these big, you know, if an economic thing happens, if a global pandemic happens, that sort of fills up your worry bucket and you're not as concerned about long-term consequences like climate change. But I want to note it's also possible that Hoosiers are actually more concerned about climate change than ever. You know, an awareness of the likelihood that catastrophic threats, which are widely predicted by the scientific community, will eventually materialize has probably likely never been more widespread than right now. Stay-at-home orders may have enabled more people to pursue resilience activities while they waited out the crisis at home. And there's some preliminary evidence from Yale, for instance, that suggests that since the emergence of COVID, the American public has become more concerned about climate change. So in other words, you know, we just don't know what's going on here. Pro-climate change views and behaviors could have increased or decreased, and we wanted to investigate to understand how these structural shifts like COVID, like the recession, like Black Lives Matter had impacted individuals' concerns about the environment. And we really had this kind of like amazing opportunity that just fell in our lap. And you know you're speaking to a sociologist whenever they're like, this pandemic was an amazing opportunity. Only a sociologist would say that. But we got to take advantage of a natural experiment where we had, as Justin said, the Hoosier Life Survey, the original wave. We had sent that out between August 29 and we stopped accepting new responses right at the beginning of March 2020. In other words, you know, it's sort of our pre-pandemic measure. We got people's views before COVID had been widespread in the United States. And in total, we had about 2,700 respondents to this first wave of the survey. And we followed that up to understand change in attitudes with, you know, what were originally very creative bunch, what we called the Hoosier Life Survey 2.0. And that ran from October 2020 to March 2021. And I want to note again that these ultimately, what I'm going to be presenting are preliminary results. So we sent out a web survey and we sent out a survey through the mail. Because of COVID, because of all that stuff, it's taking a while to process the paper version of the survey. So what I have to present right now is the web survey results only. And so that's going to compare about 570 respondents. And specifically, I'll look at just those people from their 2019 responses and compare them to what they said to those questions in 2020. And I want to note, this is probably biased in some way. These people are probably different in some way than the people who filled out the mail survey. In all likelihood, they're younger and wealthier and more urban. Those are the people who tend to have access to high-speed internet and a computer in the state. So this salt is, you can pull a grain from this salt, you know, take everything I'm about to say with a grain of salt. So I want to first talk about how did Hoosiers actually experience 2020? What did we see here? Well, we asked them, which of the following do you feel like is the most important problem facing the state of Indiana right now? And unsurprisingly, the vast majority said COVID-19, 64% of our respondents. We also saw second, you know, a distant second, but a telling distant second, I thought, was that government overreach was the second most pressing problem facing Indiana at this time amongst our sample. So, you know, given how widespread concern about COVID was here, we also asked how has the COVID-19 pandemic affected you personally? And we saw a range of responses. The vast majority of people saying, I'm spending less time with friends and family. I or someone close to me has contracted COVID. And I think this one's particularly important, a note towards the impact of the recession. 42% of this sample said I or another member of my household had work hours or cut or I lost a job. In other words, these people weren't just impacted by the pandemic side, lots of people were also impacted by the economic impacts of COVID as well. We also asked questions about the Black Lives Matter movement, police reform, perceptions of racial inequities. And we asked people to report about how their views of these issues had changed compared to what they were 6 months ago. So this isn't panel data, this is people reflecting back on their own views. Take it with another grain of salt. And I want to say, you look at this graph and it really doesn't suggest much is going on. And I would actually say you should ignore this, because if we look at this all aggregated, we're missing sort of a key piece of the puzzle in terms of people's views on these issues. So I'm going to switch. This graph is that same one broken up by Republicans in the red line and Democrats in the blue line. And we're focusing on their perceptions of the Black Lives Matter movement and if they've become much less supportive here or much more supportive here. And as you can see, Republicans have this sort of very clear trajectory. They're much more likely to have become much less supportive of Black Lives Matter, reportedly, over the past 6 months. And Democrats are the entirely opposite, much more likely to say they've become much more supportive of Black Lives Matter movement over the past 6 months. So we not only see a reported change in attitudes about racial inequity and police reform, we see growing divisions and tensions across the state in Indiana as sort of the views of these issues widen across the two political parties. Overall, 70% of our respondents said life was worse or much worse in 2020 than in 2019. In other words, it was a tough year. You know, it was hard. It's no surprise. But as you're all probably wondering, what about climate change? You've talked about the year. Now, how do people's views change? So one of the results to me that wasn't that surprising, but still is noticeable, is that Hoosiers reported hearing about climate change less frequently in the media. So blue in all of these slides is going to be the 2019 response, and gray is going to be the 2020 response. So we can see that in 2019, 36% of our respondents said they heard about climate change daily in the media. And we see a 14% drop in that for their 2020 results. So a pretty significant change. And again, this is probably because we're hearing about all of those other issues. Those are sort of taking up the finite media space, and people aren't as exposed to climate change information. We also asked them about what their household practices were under this sort of premise that they'd be at home more, they'd be more willing to take on resilience practices that we had asked about in 2019. And we actually found really rather limited increases in household resilience. I'll say personally, this was the most surprising result to me. I was really optimistic. I was kind of shouting it from the rooftops that we were going to see this change, and I'm a bit shocked. But the biggest change was in the percentage of people growing food. So we saw about a 5% increase amongst this group of people reporting that they were growing food in their own backyard. But everything else, like replacing lawns with prairie grass, was a pretty small jump. Composting food waste, we actually saw a slight decline. And a really interesting one is that about 10% of people that we saw drop in the number of shade trees around people's homes. This controls for the fact that people could have moved. So what this says is that about 10% of people cut down shade trees around their house in 2020. But on a note around climate change, there were some good signs as well. So Hoosiers were actually more likely to believe that climate change was happening in 2020 as compared to 2019. We see a 6% increase here from 81% saying climate change is happening of this group in 2019 to 87% in 2020. And this result to me, again, sort of hides the more compelling, interesting component of it, which is who changed, who actually is responsible for this 6% increase. And again, it's a bit surprising. We see here the Democrats in 2019 and 2020 are 99% believe climate change is happening. They basically can't go up. The shift was amongst Republicans. From 2019, we saw 61% of Republicans believe climate change was happening. And we see a 15% increase in 2020 to 76% of Republicans now believe in this sample climate change is happening. So this is a really surprising, it's a huge jump. You know, I think we can speculate lots of different reasons why that's happening, but to be honest, I'm not totally sure. It's really interesting and certainly surprising, but ultimately the results are, you know, there's a variety of things going on here, and this one's maybe the most shocking of them all. Okay, so I know I'm running out of time. To wrap it up, it's clear 2020 was a tough year on Hoosiers, no duh, right? Hoosiers' adoption of climate resilience practices at home appears to be limited, at least at this stage, but maybe we'll get something different with the mail survey wave. But attitudes, at least amongst this sample about climate change, could have shifted in unexpected ways. We're beginning to see some evidence that points towards that. But again, ultimately, this is preliminary and we need more research on this topic. So I just want to acknowledge the whole team, the IU Grand Challenge for funding it, the IU Center for Survey Research for helping out with a lot of the work. Thank you all for listening, and I'm happy to take questions.
Thank you, Matt. I did see a couple comments come up in the chat. I don't know if there's any specific questions. Rachel mentioned that was thinking along similar lines as Heather. It would be interesting to look into yard management. Intention leads to trade-offs in the provisioning of different ecosystem services. I don't see any questions. If we don't have any questions for Matt, anybody?
Well, I'll state my question. Is that okay?
Go ahead, Heather.
Okay, sorry. Yeah, no, I was sort of musing, but it is kind of a question, Matt, whether if the decrease in shade trees really represents, I mean, you argue that it represents a cutting of shade trees. It is possible that people cut them in order to make room for gardens or solar panels. And it might be possible to suss that out from your food garden. And I can't remember if there was a question about solar panels. But
yeah, there was, I didn't put it on here. We saw a pretty small increase. It was like 0.5% increase in the percentage of houses with solar panels. If I remember correctly, there was a pretty big jump in terms of the percentage of people who want solar panels. That was sort of the thing that bumped up. So we could tease out if there's some sort of relationship between, you know, the likelihood that you lost or you no longer have a shade tree and then another practice. We could do that through inferential analysis, and that's actually a wonderful idea. We certainly should. And you know, part of me just wants to go and like interview some of these people and like see if that's like really what they were doing, or it's just such a surprising result to me that I'm a little hesitant to like jump in it wholeheartedly. Like I kind of want to follow up and understand, as you suggest, Heather, a bit more of what people were thinking or why they answered in this way.
Great. Jerome added a comment that his experience with shade tree management this year is that neglected maintenance or removals of tree were addressed after being at home and harvesting more money to spend on tree work, et cetera. So that's another potential reason. Great analysis, Matt, thank you so much for presenting today. Rachel, whenever you're ready, yeah, go right ahead. So all right, looks like we're all set. Rachel, the floor is all yours. Thanks. And Rachel, if you
Sorry,
there we go.
I'm trying to sort out Zoom. My apologies.
No worries.
Okay.
Thank you.
I'm sorry. I'm trying to get this to be full screen. Okay, here we go. So I'm Rachel. I'm a research technician working with Matt Hauser here at the ERI. And we are working on a project interviewing farmers. And today I'll be telling you some of the preliminary research that we have developed so far. Uh-oh, here we go. So the research is part of a National Science Foundation funded project looking at the dynamics of integrated socio-environmental systems. And the research is contextualized in an interdisciplinary perspective. So it's drawing from both the social sciences and the natural sciences. And in the context of climate change here in the Midwest, drought is predicted to increase, or rather changes in precipitation regimes are expected in the future. So this will directly be affecting farmers and how farmers manage the production of crops. And at the link between the social and natural sciences, one of the focal areas for this research is on soil health, which in the context of the social sciences perspective, we're looking at soil health in terms of how farmers are nourishing the soil for long-term fertility, especially in ways that minimize the use of chemical inputs. And so over the course of the project, drawing from ecologists and historians and also the social sciences perspective, we're trying to understand how and to what extent adaptation can reduce farmers' vulnerability and agricultural systems vulnerability to current and future climatic conditions. So I'll be sharing some of the social sciences perspective thus far, starting with farmer interviews. This is the first year of the 4-year project, and we're conducting serial interviews with farmers across the region. The Indiana, Illinois, and Michigan area are the sample area for the study. So we just finished completing 90 interviews with farmers running from January to just a few weeks ago. And this constitutes the pre-planting season. And the farmers that we reached out to are a representative sample of row crop farmers. These farmers come from the Farmer Panel Survey, which is run out of Michigan State University. And the main criteria for selecting farmers in this first round was that they were either irrigators or non-irrigators. And so we'll have 2 more rounds of interviews over the course of the year. Mid-season, later this summer, we'll be following up with farmers who either had conventional or more progressive soil health management practices based off of what they reported in the first conversations. And then at the end of the year, post-harvest, we'll talk with an even smaller subset of the farmers to hear their reflections on management practices. So here's just a quick image of where the farmers come from, who we've spoken with. As you can see, it's across the tri-state area. And the breakdown for the 90 farmers that we spoke with, 30 of them were irrigators and 60 were non-irrigators, spaced evenly across the 3 states. And this reflects the general ratio of if farmers are irrigating or not irrigating across the Midwest. And to talk with farmers, we used a semi-structured interview guide. All the interviews thus far were conducted over the phone just because of COVID. That made things easiest. And in the conversations, we covered 5 main areas, looking at the kind of a farm overview, hearing from farmers about the farm size, the crops they use, their fertilizer management programs, how they till, the decisions that go into how they run their farm, and then specifically talking to them about soil health, trying to understand if they are familiar with soil health, how they manage for soil health, why they value or don't value certain things related to soil health, water management, looking at irrigation, but then also drainage is a big issue for farmers. And the last part of the interviews, we focus on topics related to the future of agriculture, both on their specific farm plots and then also their perspectives on the future of agriculture across the Midwest. And likewise with climatic conditions, asking them questions about their personal experiences, what are the main weather events that they deal with day in and day out, and then also what they think about climate change as a whole and how they feel agriculture will fare in the future, how they will cope if they're concerned about that or not. So it's been really interesting getting to talk with all these farmers from across the states. And preliminary findings thus far, we're currently coding everything in vivo, and quantifying the results. But preliminary findings thus far are that most farmers that we spoke with value soil health. The majority are familiar with the concept, and nearly all believe that it is important, citing various reasons, but the key things that kept coming out are the economic benefits of soil health, the environmental conservation value of soil health, some farmers citing both. And what was interesting too is that most farmers who are familiar with soil health indicated that they are actively promoting soil health, either through one management practice or even multiple management practices stacked on top of each other. And again, many farmers familiar with soil health indicated that they want to learn more or do even more to promote soil health on their farms. There does seem to be some bias in soil health management practices, which was really interesting as well. The majority of farmers indicated that they thought that their chosen management practices promote soil health, regardless of what that management practice actually was. So when farmers are talking about tillage or drainage, cover crop usage or not usage, how they manage for fertility on their fields, almost everyone felt that they were promoting soil health. So for example, taking tillage, farmers could be doing more conventional deep tillage practices where they're going in and turning the soil over all the way to the other end of the spectrum of no-till, where they're planting more or less directly into the surface itself. And both of these practices have really different consequences for the soil structure, the amount of carbon that's either stored or released into the atmosphere, the effect on the bacterial and microbiology in the soil. And on both ends of the spectrum, farmers really believed that their practice was promoting soil health. So this was just fascinating to kind of pick up on in conversation with farmers, and also to hear other farmers reflecting on this very thing. So I pulled out here 3 quotes for you of farmers reflecting on how they really think that everyone thinks they're doing the right thing. So one farmer says that, different guys have different values on soil health, or everybody seems to know that you need healthy soil to try to get the best yield and make the most income, but there's a lot of different opinions on how to go about it. And I really loved this farmer who shared that he felt that probably in everyone's heart, they believe they're a steward of the soil, that they all think they're doing a good job. So this was all just really interesting to hear from them. And then looking at the information that's been emerging around weather and management practices related to the weather, really the almost unanimous concern is that there's too much or too little water at the wrong time. Farmers were often telling me that they complain all the time about the weather, which they just want perfect weather, and it's never perfect. But the perception of irrigation, if farmers saw it as a valuable thing for the present or future adoption, a lot of the perception around irrigation seems to be tied with their personal experience with the local moisture conditions at their farms, and then also seems to be affected by the actual lay of the land of the farm, if it's flat versus rolling hills, the actual soils, if they are well-draining soils or if they are more moisture holding. These types of things really affect the farmer's perception of management when it comes to irrigation. And then also the economic return on investment. It's expensive to install and maintain irrigation systems, but the payoff for higher yields is also there. So farmers wear many hats in addition to just growing crops. They are business managers. And so this was a common thing that came out of the conversations with farmers thus far. And in terms of climate change and farming, these were really interesting parts of the conversations. And it seems like many farmers do believe that climate change may be happening, but they're doubtful of humans' role in climate change. And so there were also mixed perspectives when I asked them questions about if they think that climate change might be leading to more extreme weather in the future. Some certainly said yes, others said no, but in general, most believe that regardless of what weather comes their way, that their farms will be able to cope with the changes. It is also interesting that some farmers really do have concern about climate change and that they are actively doing things on their farms now to try to build resiliency in the face of changing weather conditions. And so one farmer in particular, I'll share a quote with you from but he was indicative of other farmers who are seeing soil health as a means for building farm resiliency. So he really captured that concept here. He told me that tying back into soil health, his way of augmenting, not investing in irrigation, is that if I can have better soil health, that will help not only absorb the water, but keep it so the plants can continue to utilize it. If we don't have a lot of organic matter, particularly in the soil, the water just goes right down. So we may have a good rain, but after 3 or 4 days, the water is gone. So what do you do now? So that's why I'm thinking soil health is the way to go. So it's really interesting to hear his thought process on this, especially because it does tie into really all of the concepts that we were hitting on in the interviews, tying into soil health and management practices and irrigation and climate change. So it's really exciting to have all of these conversations with farmers and see what's emerging from the dialogue with them. And so as we're coding this and quantifying the responses, we're also simultaneously preparing for the next round of interviews, which are coming up sooner rather than later. And so the directions for future inquiry, things that have kind of emerged from this initial round of interviews, we would like to learn more about farmers' management intentions and how those either materialize or don't materialize into action later in the season. Basically, is what they say they want to do, what they actually do. And looking at, well, asking them what went into why they were able to achieve what they wanted to, or what deterred them from implementing their plans. And then hoping that we can take this information and make it useful for other farmers who are probably facing or possibly facing similar challenges on their own farms. And we're also curious to learn about why farmers who are pursuing soil health, why they're doing so, even if there is a lag time in the direct benefits that they're seeing. Because oftentimes the benefits of soil health may be years out. And so it's really interesting to hear from some of these farmers who are very focused on the short-term profitability of the farm as the primary aim, versus farmers who are obviously concerned about profitability, but have more of a tendency to focus on the soil health and the potential benefits down the road. So we'll be looking into this later this summer as interviews progress. Thanks so much for letting me share this initial preliminary findings. And if you have any further questions, I'm happy to field those now, or you can reach out to Matt or myself via email. And I'd just like to also acknowledge that this is part of a collaborative effort. So many thanks for helping get the interviews completed, and that this is the first of a 4-year project. So the soil testing that ecologists are going to be conducting is down the road, and it will all tie in to the overall project. So, thank you.
Thank you so much, Rachel. You did have a couple of questions posed in the chat box.
Okay.
I'll be happy to read them.
Sure.
So Nathaniel Geiger states, the insights into other farmers' motives is really interesting. Some work suggests that in some cases, people tend to perceive that others are motivated by self-interest more than they actually are. Looks like that misperception may not be the case here, though. Can you?
Well, again, this is all preliminary information. So much of it's coming from just looking at all the different responses from farmers, and we haven't quantified it yet to be able to really answer that. But it does seem like there's just mixed perspectives on that. Some farmers are really focused on what makes them profitable here and now, and others have kind of a general, a bigger picture or more holistic picture, perhaps, as to what goes into farming.
Perfect, thank you. And Heather had Heather Reynolds had posed a question in the chat box also. Heather, would you mind posing that to?
Sure. Yeah, I was just curious, and I may have missed it. I know you've got the irrigated versus non-irrigated farms. That was the primary split, but presumably you also have a breakdown of farms in terms of whether they're organic or conventional, also their farm size and their crop focus, whether they're specialty or commodity, because it seems like all of these things, and also in light of Matt's, Hoosier Life survey, political affiliation, seems like these could all be important covariates in terms of how they choose, how they feel about climate change and whether or not they're supporting soil health and why. So just curious if you plan to do those types of analyses.
Definitely. And Matt probably can speak best to what the actual analysis will look like. But we definitely do pick up on that in the conversations as to if they're farming in an organic or more conventional sense. And because of the nature of interview research, any conversation is able to follow the line of what emerges from a specific farmer's experience. So there is a lot of really rich data that comes out of conversations with those rather unique farmers who have specialized in organic crops. And I say unique in the terms of row crop farmers, because in the row crop world, we're talking about hundreds, if not thousands of acres, and it's typically conventional, typically just corn and soy. So when I do have a conversation with a farmer who happens to be farming organically or farming for a niche market, it's kind of exciting because they are just an anomaly almost. And so those conversations I do try to learn more about what goes into the decision-making of how they even got into that in the first place.
Rachel, Matt, could either of you kind of touch on the timeline for the project? I think you mentioned a second round coming up, but 4 years project work. So can you maybe just talk about the timeline a little bit, when the project will finish up and end deliverables will be available?
Matt, take it away.
Me? Oh, you put me on the spot here. We'll end deliverables, so we'll probably make things available as we go along, and as we have each, I would view it as a series of data sets we're collecting. So this sort of year one data set, as we get that processed and published per NSF guidelines, we'll put it up online and it will be available. Everything will be, I'll say it this way, you won't be able to know who said what, but the quotes and information like that will be accessible. The ecologists also have a plan. I'm not totally sure when their work will be done in terms of shareable, but by year 4, so I think at that point, that's 2024 right now, we'll be delivering that information back to farmers. So their analysis should be done at that point, and we'll have data for them. And then our end of project, will be, if I'm remembering correctly, December 2025 will be ultimately done. And shortly after that should have sort of our final 2 years of interview data available and done.
Thank you. Any additional questions for Matt or Rachel before we kind of switch gears into the next set of presentations? Perfect. We are 1 minute ahead of schedule. So with that, I am going to turn it over to Kimberly Cook. Kimberly has been with us as a data management assistant since March of 2020. And she has been very helpful in documentation specifically and interviews with researchers. Many of you may have had an interview with her. She will be leaving us this summer to join a PhD program in the University of Kentucky. And I just wanted to take a moment to thank you, Kimberly, for all your work with me and for me. So with that, Kimberly's going to talk about some of the, data descriptions, a draft of some data descriptions. As you all are aware, today we looked at several different types of data, and to kind of standardize or make data sets more descriptive and in a process that would standardize almost all of our data sets, she has began to put together an initiative to kind of put together some standards. So with that, I'm going to turn it over to Kimberly and let her present on that. Go ahead.
Yes. Yes, I will share my little screen here. Presenting mode. All right. Can everybody see my screen, hear me, all the things? I'll move you down here. All right. So like Justin said, my name is Kimberly. I'm the data management assistant for the ERI. So I've been working with Justin for the past year on a variety of data projects. And as the ERI is moving into this sort of next phase with our new leadership, and as all our research associates and researchers gather their data, we're starting to think about how we can better integrate those data and as well as work across both ERI researchers and get the word out about ERI data for external partners. So lately we've been working on putting together another caveat that seems to be the the theme of today, preliminary data description standards, subject to change, but this is sort of the basis. So to start with, we have these sort of two different categories. We have, the basic description guidelines. So these are just basic expectations for all of ERI data sets. And then on the right, you'll see a list of, best practice, which sort of brings in the basic and then adds a little, something extra, the whipped cream on top. So starting on the left side, so the basic description guidelines start with having a descriptive file name. So something that tells us something about your data set that that just tells us something, that can be the project name, that can be who collected it, when it was collected, something that matters about your data set that you want people to know. Secondly, describe your units of measurement and how those units of measurement came about. So even if you think it's obvious in your tabular data set, for example, you might want to go into more detail about your units and where they came from. Also, derived data products. It's really nice and lovely to reuse data that already existed out there. We love doing that. We love when that happens. But it's important to describe how you took that pre-existing data set, what you did to it, and how it fits into other data that you either collected or maybe collated from other resources. In addition to that, sort of crediting the original data creator, data generator in that project that might have created that data. And of course, there are some sort of nuances that go along with that, but basic requirements. And lastly, everybody loves metadata, right? Try to have a metadata standard. A lot of disciplines have working groups working on metadata standards for that discipline. But if you feel like you can't find one that sort of fits your data needs, you don't think that it's structured the right way, or there's another issue with it, try to have a data dictionary where you might have come up with your own variables and your own variable descriptions, but have a sort of separate document where you describe each variable, where it came from. And actually sometimes you might have a variable description in your head, and then you might have written it down or named it something different, like an alias in your tabular data set, for example. So try to have a data dictionary that draws those connections, that makes it easy for someone who was not involved in your research project to understand it and how it all fits together. So building on top of that basic layer, it's also important, best practice, to have your data types match your data fields. This is a common issue with dates, for example. So to start with, you'll want to make sure that all of your dates are the same, structured the same way, and make sure that your date fields are in fact indicated as date fields rather than general text or decimal, something like that. Pretty simple stuff, but just double check it. You also want to have a point of contact for your data sets. So this is ideally someone who is perpetually involved with the data, perpetually in the same position to be able to access the data and either answer questions about it or give and redistribute the data as well. Ideally also someone who has had contact with the data in its generation. So someone who's worked with it or gathered it, something like that. Thirdly, unique identifiers. Things like DOIs. So IU Libraries is capable of minting DOIs for your data sets. That's just one example. There are other ways to go about doing this. And again, there are a lot of nuances associated with unique identifiers for data sets because, if you have a ship, you replace all its parts, you have this other ship, is it the same ship, that kind of thing. And again, that's sort of a case-by-case basis, but it's good to have that the notion of a unique identifier in your head because you can connect your data set to any publications that resulted from that data set. And also if someone reuses your data, they can point to that specific DOI, and that sort of takes care of the problem of versioning. So which version of the data set they used. And lastly, standard vocabularies from your discipline. So information science, we call this ontologies. So you want to make sure that, for example, the term animal means the same thing for your users. That's kind of a simple example, but and making sure that what the standard vocabulary is for your discipline. And this is kind of a more complex thing, more nuanced, and the data team would be happy to help either find things or help you figure this out. So all of these, zooming back a little bit more, these description guidelines will be provided in a document with further descriptions about what each of those means, as well as links to external resources. For example, for the metadata standards, it will have links to specific metadata standards that might be applicable to ERA research. And so building off of that document, we're working on trying to think about how to work better between the data team and research teams based on this sort of data description guideline. And so this sort of draft workflow, the idea, the concept is that the data team will review ERI data sets for completeness based on the description guidelines I just described. And then the items that remain to be addressed will be communicated to the research team through a shared document, sort of a checklist type thing. And then with support from the data team, the research team will be able to ensure their data descriptions are complete. And then finally, with better data description, ERI's data and research is more visible to an outside audience, because that's what this is all about. We want to communicate across ERI researchers and with potential collaborators in the future. So that's all I have now. Again, this is a work in progress, so you might hear from the data team about providing feedback to us about the workflow and the documentation, but stay tuned. This is coming in the future, and thank you.
Thank you, Kimberly, again, for your work on that and the presentation. Do we have any questions for Kimberly? Again, this is an early stage of a draft, kind of like a standard operating procedures that we're trying to put together to, I guess, get a handle on all the different types of data being generated from all the various research groups within ERI. All right, if there aren't any questions for Kimberly, I am going to share my screen and I will present the final presentation for today. I do not have a PowerPoint presentation. Instead, I want to do a live demo and I guess expose this audience to a few data resources and tools that we are making available through the ERI. So I am at the ERI homepage. From ERI homepage, I want to look at the tools and resources page. And I want to just highlight some of the tools and resources that we make available on this page because we're going to be talking about the data resources page. So within that tools and resources, we've stood up a page that kind of displays the, I guess, the various data sets and data repositories that we kind of are incorporating into our ERI data platform. So when we look at the ERI data platform, I'll show it here in a moment, but I want to highlight the data sets that are made available on that ERI data platform. So we've got several repositories for statewide data. The Indiana map we're all aware of. I'm sure the Indiana map is a large repository for Indiana data. Many of those data services are going to be migrated to state government. State government has, similar to Indiana map, they have data services or GIS services that we can kind of tap into and bring into our data platform. And then there's also at IU, we have a product called ArcGIS Online. And the UGI Green City Mapper, all of the content that is hosted on that, all of that content is hosted on this ArcGIS Online environment, and that is made available through IU through a standard software license with Esri. So these Indiana open data sets, I want to highlight those three different repositories. They're all kind of storing spatial data. And then we've also got down here some other types of data resources, including some future water, and as Matt and Rachel were just talking about, the Hoosier Life Survey. These are different data sources that you can, I guess, go look at the actual pages and view them. But we're hoping to kind of bring these independent tools bring the data behind these independent tools all in one place through an ERI data platform. So while the Indiana Green City Mapper is focused primarily on urban data sets, urban green city data sets, we may have other researchers like the Future Water data set producing their own standalone tools, but we kind of want to bring all of these data sets into one, I guess, viewer or one data platform. And then there are some additional data sets that we subscribe to. So one, for instance, that I want to highlight today, and I'll show you how to access this momentarily, is that ERI has entered into a relationship with Planet Labs, and Planet Labs provides daily satellite imagery for the whole globe. They also provide services similar to Indiana Map Services, in that there's a data stream you can just stream into your applications and access their imagery in tools that we develop. So with all these different data sets described here on data resources, I'm going to kind of walk through several of these different data sets and show you how you would access them. I'll just go ahead and start refreshing the page. So what we're looking at here, eridata.iu.edu, this is your main default what loads when you visit the page. The first data set that I want to walk through is what I just mentioned, the planet satellite imagery. So you get some instructions here to begin with. You can read through those on your own. What I'm going to walk through now is the adding satellite imagery to a place. So let's say I just want to zoom into a specific site. Many of you may come down from Indianapolis down to Bloomington and have to go through Martinsville right now. And many of you know Martinsville, the highway is shut down right now because of I-69 construction. So I want to demonstrate or visualize some of that environmental change taking place. I'm looking at right now base maps, Esri base maps. So if I want to change my base map to an Esri base map, I can do that. Imagery hybrid, change it to imagery. So these are base maps that are provided by the vendor, ESRI. This is common functionality that you'll find on many tools, including Hannah demonstrated earlier, this functionality on that UGI Green City Mapper. What I want to bring your attention to is not the base maps, but the subscription service that we have subscribed to with Planet Labs. I can go all the way back to 2016 and look at what the imagery was in August of 2016. And this is pulling it in right from Planet Labs. So this is satellite imagery for 2016. And if I go now and look at 2021, just last month, as soon as I do this, you'll notice the large construction project taking place right here in I-69. So we can actually see, that visualization of the environmental change. Back in February, before the construction season, some of these were not as large. Some of these right-of-way cuts were not as large, and we also had some snow on the ground. So this is not just for Indiana. I want to, Amazon rainforest, Amazon Brazil, there we go. Take me there. So if I want to monitor the rainforest, actual deforestation in the Amazon, we can zoom into an area and see what it was in 2016 or 2021 or 2018. You get the idea. So we do have a 3D globe right here. So I can spin this globe, go out and look at the whole globe. But by adding this temporal data, we now actually have a 4D visualization of anywhere on the globe. So this is important, knowing that many of our data sets are specific to Indiana. However, we do have several global data sets that are being generated, climate modeling, for instance, or even regional data sets that will cover several states. So that need for a tool that is a global tool and not just specific to the Indiana geographic extents is what we're fulfilling here. I'm just going to refresh the page. So I highlighted or demonstrated that Planet Labs monthly satellite imagery. Know that that's there. Again, anywhere on the globe, not just within Indiana, that is available. I want to switch gears now and go over here and start highlighting some of the open data sets that are available on this tool. Looks like I've got 15 minutes. So I mentioned in our data resources and tools page, we have several repositories for Indiana open data. The Indiana map has long been the repository, a repository for geospatial data for Indiana. So all of the map services that are on Indiana Map are available here. And if you want to just start typing, you can identify by what environment, or as soon as you start typing, all of those layers that match your query string are brought in here. So I typed census, and now I have several census layers. I can bring one in just by clicking it, and then we'll see that it's actually drawing. This is requesting it from the Indiana map, so it takes a little bit, but there they are. Again, I'm going to remove that now. And in.gov, similarly, if you have imagery or another layer from the indiana.gov, you can add that layer here. That's a second repository that's not housed at IU. So you can see there, I just brought in aerial photography from 2011 to 2013, and that was brought in from the in.gov state GIS server. I mentioned earlier, I'm going to refresh this real quick. I mentioned earlier the IU ArcGIS online organization. There is a lot of content being placed in that organization right now. So an example would be if I want to maybe go down here and look at the floodplain, I can go to the IU ArcGIS online. And I know that we have a layer in here called floodplain. So as I start typing flood, it will populate. And then I'll get a list of all of those layers that actually meet my criteria eventually. And we can see that the 100-year floodplain comes up to the top. And this is a layer being brought in right from ArcGIS Online, a cloud-hosted environment. We have all of the floodplain, the 100-year floodplain right here. And if I want to go in and see where that is on a 3D look and see, you can do that. If I wanted to add a little LiDAR data to that to really give it some, I guess, elevation context, you can do so and then adjust the transparency once this is brought in so that you'll actually get a much better look at the digital elevation model that's that's available here. And if I want to kind of adjust that, I can see, oh, maybe adjust the transparency to show, that actual creek bank or the digital elevation that I'm looking at here. And I can look at those elevation models as they relate to that floodplain area there. So 3 repositories of geospatial data for Indiana that we just covered. And then this last one is Indiana map content that is being migrated from the Indiana map server to ArcGIS Online. So several of the Indiana map layers, or many of the Indiana map layers, can be hosted on ArcGIS Online rather than through an ArcGIS server. And that's what we're looking at here. So these are basically all of the Indiana map services that have been migrated to IU's ArcGIS Online. And I can bring any of those in. And if I want to look at the building footprints and maybe look at those building footprints that are in the floodplain, I can do so right here. So I can see the floodplain and see these individual buildings that are inside there and maybe do some analysis or something along those lines. Okay, so that is the Indiana open data sets. I've got about 10 minutes left. I want to cover two other types of data sets that we're making available. I just refreshed the page to refresh the map. I want to now focus on some of the curated data sets. So we have, again, the Indiana open data sets, but we also have, there are several data sets that we want to make available through a data platform that are not specific to Indiana or not an Indiana state government. Many of these, like tree canopy, national flood hazards, several of these are national data sets or US specific data sets. But there are also global data sets like this artificial sky brightness. Again, that's a global data set. So something, trying to view something like this on a smaller extent in like an Indiana map viewer or an urban green city map viewer may be a little more difficult. So these global data sets, having a global viewer to allow for that will, I guess, allow you to view or interact with data sets that are not just local to Indiana. Each one of these data sets are kind of described here. So as I go down here into, the ERI data platform, we have the ERI curated data sets. So what we're looking at there, we have descriptions of what these are. As I go to the viewer, We only have a small description and a link, out to the individual data sets. But if you want to go back to our ERI resources and tools, every one of those curated data resources has a small description here and why we think they should be included on that data platform viewer. So with that in mind, if you think you would have, or you can identify a specific data set that would be of use or that you think should be included on an ERI data platform like that, please send that data set or a link to the data set our way, and we can see if we can incorporate that data set into a viewer or make it somehow accessible in some of our online tools. All right, I'm going to not spend much more time on the curated data sets, but what I did want to demonstrate on the ERI curated data sets, now that many of these, did I not have that in there? I thought I did. Now that many of these UGI data sets are being made available, I envision those kind of showing up here either on their own folder or in an ERI curated data set. So we can bring those in to, I thought I had it on here, but I didn't. Several of those layers that are on that Urban Green City Mapper can also be included in here just as checkboxes like many of these other layers, like we got a tree canopy layer. So I envision several of those layers that are available on other tools to kind of show up in here as either checkboxes or their own individual folder like that. Another one that may be of interest to some of the biology folks, you choose a species and then you say show the habitat for that, and it will eventually bring that habitat for that species in. And it turns out that that bat is not really present here, but it is present in the southwest there. So you can look at the legend and see that, yes, during the winter, and the habitat for that species is right there. Okay, so I only have maybe 5 or 6 minutes to allow room for questions. So I want to move along to bring your own data. I'm going to just refresh the view again, and bring your own data can be anything from, there are several different types of data and several more in development that will be included in this. But one of the biggest ones right now is the ArcGIS Online Feature Service. I mentioned several of our research groups are storing their data and making their data available in ArcGIS Online. And if that data is available in ArcGIS Online, you can bring it into a tool like this. So we have another project called Future Water that's been supported by the Environmental Resilience Institute. And that has data that's hosted here on the IU ArcGIS Online environment. I'm just going to go get that data. I just copied a URL and I'm going to place that URL in here and add it to my map. And then we will be able to pull in the future water data. And if I want to get that watershed's name and for 2020s, for the 4.5 scenario, here are your results for future water. I don't have a lot of time to really go into these variables for future water. I would, I guess, recommend you look at future water and seeing how you could use this data. But this is one way to do that. Another one, well documented, we have another project called the Hoosier Resilience Index, and it too has most of its data housed within ArcGIS Online. Again, I can just copy that layer and add it to my map, and now I have the future water data in there in addition to the Hoosier Resilience Index data in there in addition to the future water data. And this gives us, how many days of above high heat days or low heat days, et cetera, et cetera. So these different data sets are used in standalone applications that highlight their specific data, but once that data is stood up in formats like this, it can also be brought into tools like this. One last thing on the Bring Your Own Data tab. If I zoom in to a specific area and I'm looking for geospatial data, IU has a repository of spatial data through the Indiana Spatial Data Portal. If I zoom into a particular area and I say Indiana Spatial Data Portal files, it will take the extent of where I was there and then give me all the data available. So if I wanted to download some orthophotography for that specific area, or if I wanted to get some additional data from past historical data sets, all of the data that's stored on the Indiana Spatial Data Portal is queried, and you have access to it through a tool like that. So one final thing I want to bring up is the select screenshot area and some measurement tools. So if I wanted to, let's say, go in and measure, a site for some field work or something, I could actually go in here and get a 3D measurement instead of, those 2D measurements that are normally on a straight looking down map. This is giving me an elevation contour from this point to this point, 465 meters. If I wanted to draw that polygon, I could do so. And this is a 3D polygon. And let's say I want to put that in acres. There we go. I'm looking at a 49 acre parcel, but that 49 acre parcel is now showing you a 3D measurement instead of a measurement that's only using 2D. So you can see, if I measure from this point over to here, it's a straight line instead of following the topography of the land. So this is a really good way to do some advanced measurement through anywhere on the globe. And it'll show you that flat line, this hill crest goes above that plane, that 3D plane that is measured this 49 acres. And then if I really like what I'm doing here, I can select a screenshot area and say, give me a screenshot of that. And it'll download image. And now I've just created a screenshot of that area, and I can save it to or send it to. All right, that was a whirlwind tour of the ERI data platform viewer. And I only have a couple minutes. I want to wrap us up by noon. So if I can ask any, or if I can answer any questions or answer any questions offline, I'd be happy to do so in the next couple minutes. Otherwise, I would like to take this opportunity to thank you all for participating. This is a really nice turnout and a great presentations. And I thank you so much for all those that have presented and shared what they've been doing. With that, I'll turn it over if there's any questions. Great. I threw all that at you and there are no questions. I must have done a great job. Okay. Thank you again, everyone, for your participation. And I think we can close it up. Bye,
Thanks,
everyone.
Justin.
Thank you.